Hey folks, in this video we're going to be talking about chemical reaction basics, or basics of reactions. Let's go, prowl! I want you to be able to explain the basics of interpreting chemical reactions, and that's it. So now, let's make it happen. So when we talk about reaction equations, they're going to show how chemicals react together to form new chemicals. And so usually they're going to look like something like A plus B come together to make C. Or we might see something where A falls apart into two different things, becoming B and C. So one thing that's important about a chemical reaction is they're going to show the proportions required for that reaction. So you might need two of those A dudes to react with one of those B dudes to come together to give C. Or you might find something with more complicated proportions, with three of those A dudes coming together with four of those B dudes, and smash together maybe to make two of those products. C. Or for a real example, you know, if I'm riding my bike, I'm going to need two wheels to go onto my bicycle for it to be a functional thing. So two wheels plus that frame should give my bike, plus a whole bunch of other components. Or if you were to find a daisy, a little pretty flower, and you were to pluck that thing apart, you would end up with 5 flowers, or 5 petals plus 1 stem, because daisies, unless they're mutants, always grow with 5 petals. So another important thing that's going to be shown in our chemical reactions is the state of matter for each chemical in that equation. We're going to want to know if chemicals are solids, liquids, or gases, or maybe aqueous, meaning dissolved in water, during a reaction. Because, before I go on, it's important to know that, you know, if you need to have a gas for a reaction to occur, and that's important to know, particularly if you only have stuff in a solid form, you're going to have to turn it into a gas to make that reaction go. So we need to know the state of matter. And so reactions are always going to show our reactants forming products. Here, I would call these guys the reactants. I would call C the product. Our reactants are going to, with an arrow, or the other way, become our products. And so they're always going to be separated by that arrow. Fun stuff. So going into a little bit more detail about the different parts of a chemical reaction. Our reactants, again, we've said, they're always going to be shown to the left of that arrow, and they're always going to become the products on the right-hand side. So our reactants are destroyed, or more appropriately, we can say chemical bonds in our reactants are broken, and these are broken in order to make the products during the reaction. And so one thing that's very, very, very important to know, and we'll talk about more in the next video, is that the number of each atom on the reactant side must equal the number of each atom on the product side. So if I've got like 2 chlorine atoms, rather, on my reactant side, I need to make sure that there are then 2 chlorine atoms on my product side when the reaction is complete. So the products, those are going to be shown on the right side of the arrow. And yeah, these are created during the reaction by rearranging the atoms in order to make those products. So, okay, cool. There's these other things in here that are going to be very important. These are subscripts, and these show how many of each atom there are in a particular molecule. So this dude here, C2H6, this little 2, this subscript, and we know it's a subscript because it's found below the rest of the scripts, kind of like a subway is below the ground, or a submarine is below the ocean surface. Anyway, this 2 tells me that there are 2 carbons. This 6 tells me that there are 6 hydrogens in this compound. And it's very important to know the proportions that elements combine in, because that makes the chemical. Our subscripts can't change. If I start to change the subscripts in here, then I'm totally changing what the chemical is, and that's going to change the chemistry, and that's going to mean it's going to react in a different way. But seriously, don't change those subscripts. Seriously, don't do that. So when we're looking at a reaction equation, coefficients are a thing that come up, and these indicate how much of each molecule or atom is present. Our subscripts give the formula for each molecule. Our coefficient tells us how many of that molecule we need for the reaction. If no coefficient is present in front of a molecule, we can assume that there's only one of them there. So in this guy here, we know that there are 2 of these A's combining with 1 B to give us 1 C. 2 A's and 1 B are needed to make one of these C's. In this real life equation that I've goobered up, let's fix that, we have 1 nitrogen reacting with 3 hydrogens to give us 2 of these products, ammonia. So yeah, 1 nitrogen, and this says 6 again, let's fix that. And 3 hydrogen molecules are needed to make 2 NH3 molecules. Neat. And so we can change these coefficients or rather, well, I changed these ones here. But when we need to balance an equation, which we'll talk more about in the next video, we will change these coefficients to make a balanced equation. If I just wrote N2 plus H2 gives NH3, the reaction would not be balanced. I would have 2 nitrogens on this side and only 1 nitrogen on this side. So our coefficients make sure that we're not messing up and having an unbalanced equation. So more on that later. But seriously, don't think about changing those subscripts. So states of matter, these are important. As I said before, we need to know what state of matter chemicals are for an equation. This reaction up here really only works well when these dudes are in the gas phase. If they were solid, it would not work very well at all. And so, like I just said, solids and gases are not going to behave the same way. So the subscript letters that are in parentheses after each chemical, those tell us the state of matter, like this G, and this G. And so I've got some examples here. The G under that N2, that stands for gas. The L next to that H2O stands for liquid. The S under the NaCl stands for solid, and the AQ stands for aqueous, this little AQ over here. We're not going to really look at things in the plasma phase of matter, so that's that. Anywho, that's the end of this video. I hope you feel like you can look at chemical equations and have an idea of what's going on, what all the numbers and letters mean, and yeah, generally how to interpret those things. Ta-ta, and have a great rest of your life.